Hello, we are the OpenStack Octavia team. We are Dawson Coleman, Luke Tollefson, Stephen Glassford, and Noah Mikas. OpenStack is a cloud platform already in use by many Fortune 500 companies. It is an open source project governed by the OpenStack Foundation. There are many organizations already using OpenStack that you may have heard of, such as AT&T, Walmart, Intel, Comcast, Red Hat, and even scientific organizations such as CERN. Octavia is OpenStack's load balancing as a service project. So what is a load balancer? Obviously, your app is awesome, and you might start with a small number of users, but over time, your user base will grow. And inevitably, more and more users will come along, and your one server will get overrun by all your users wanting to use your website. So instead, you set up a load balancer. A load balancer is just another server that sits in front of your content hosting servers. The load balancer receives requests from the outside world and distributes them evenly among your servers. So you can scale up as much as you need. If you have twice as many users, just add twice as many servers. Everyone's happy. So our task was to enable configuration of TLS protocols and ciphers. TLS is the protocol that encrypts lots of our communication on the internet today. And obviously, if you're hosting any sort of website or any sort of service, you want to be able to configure that. Of course, there have been many different versions and ciphers that TLS has run on top of over the years. The latest being TLS 1.3, but it's not necessarily supported on all devices. Ciphers determine how the information is encrypted. Different devices support different ciphers, so what you want with them will depend on your application. Before, there was no way to configure your TLS protocols or ciphers in Octavia. You were left to deal with whatever the default was without much way of knowing what they were. This didn't give operators much control. For example, if you're running a website like YouTube or Wikipedia, you might not care so much about having the strongest encryption. You might instead care about having encryption that works on most users' devices. However, if you're running something like a bank or stock exchange, you may want to beef up your security because you're dealing with financial transactions. So now that we've added the ability to configure these things in Octavia, let's have an example. A listener is simply an entity that listens on a port for incoming traffic. We have added two new options for configuring Octavia, and these are surfaced through two new flags in the CLI, --TLS ciphers with the cipher string, and --TLS version with the TLS version. You can use this to add multiple TLS versions that you want. So in this example, we can create a new listener. We have OpenStack load balancer listener create with all the typical options for an HTTPS listener. And highlighted in green, we have our new TLS ciphers option where we pass in a TLS cipher string that will dictate what ciphers are allowed to be used on the listener. Let's go to a live demo. To demonstrate, I'll set up a new listener with a custom cipher string. So we're starting off on my Ubuntu server VM. Currently, we have no load balancers, so let's create one. Octavia will now go provision a VM that the load balancer will be hosted on. All right, now we can see it is online and active. Now we can create a listener with a custom cipher string. For our demonstration, we'll just use one cipher. There's nothing special about this cipher in particular. It's just one that we can use and test to make sure that it shows up on the listener when we try to connect to it. As you can see now, our listener is listed as online and active, and we now have this TLS ciphers string here. Now it will only accept connections with this TLS cipher. We can test the connection using a tool called OpenSSL S-Client. We're passing this cipher flag using the same cipher that we set up the load balancer with. If it works, we should expect this connection to work just fine. As you can see right here, we get our TLS AES 256 GCM SHA-384 cipher. Same one that we expected. Using this option, you can use any OpenSSL cipher string that you want. And as it turns out, there's quite a few ciphers. Yeah, you have a few to pick from.